All right, so taking a look here. So what did you guys put for the first one? Plugging x into f of x. What is that going to find, Brady? Plugging x into f of x. Very good. The next one, the point 0, f of 0. What is that going to be called? Max? When we plug in 0 for x and we get an answer. Y-intercept. What about if we set the original function equal to 0? What is that going to find? Rachel, do you know? And we can have 1, or we can have more than 1. Now with a y-intercept, we can only have 1. Does anybody know why we can only have 1 y-intercept? Yeah, if we have 2 y-intercepts, it does not pass the vertical line test and it's not a function. All right, critical numbers. To find critical numbers, we set f prime equal to 0. Remember that f prime is going to tell us the slope at any x value. So what about when f prime changes from negative to positive? What do we have there, Aiden? A relative? Go from negative to positive. Men. Relative men. And what about the next one? When f prime changes from positive to negative, we have a relative, Adriana? Max. So when does f prime of x not exist? There's 2 times that it does not exist. Tasha, do you know? Vertical asymptote is true. Where else? Cusp or sharp turn. Good. All right. Possible points of inflection. We set the second derivative equal to 0. What does that second derivative find for us? Cooper, what's it find? Concavity, good. Claudia, if that second derivative is positive, what does that mean about the function? Concave up, right. Lauren, if that second derivative is negative, what's going to happen? All right, for rational functions only. So these rules only hold true for rational functions. Rational functions mean that we have a fractional function. So we have some kind of expression on the numerator and some kind of expression in the denominator. That's what we mean by a rational function. So, Chris, when do we have vertical asymptotes? The x values which make what? The denominator equal 0, yes. So in this case, x squared minus 4, Haley, what would be our 2 vertical asymptotes on that? Right, it would be positive and negative infinity, or 2 rather, not infinity. Horizontal and slant asymptote rules. When the degree in the numerator rather, is greater than the degree in the denominator, what do we have in that case? Slant asymptote, good. How do we find slant asymptotes, everyone? Find it with synthetic division, yep. Just to refresh your memory on that, let me change this problem. Let me change it to x squared plus 1 over just x minus 4. Before, we would have had a horizontal asymptote here. So let's look at this last rule. When the degree in the numerator equals the degree in the denominator, then the horizontal asymptote is y equals the coefficients of the leading term in the numerator divided by the coefficient of the lead term in the denominator. So what do we get back here if we divide those coefficients? Just 1, right? So this has a horizontal asymptote of y equals 1. Remember, horizontal asymptotes are the same thing as the limits as x goes to positive or negative infinity. Now, on this one, though, all I did was took away the x squared. Now this is a higher degree than this one, and we have a slant asymptote. So we just said that we can use synthetic division. What is going to make that denominator 0? 4. Here's how we do it then. We put 4 in the box. The coefficient of x squared is 1. Coefficient of x is 0. And then we have our constant. We bring that down, we get 1. 4 times 1 is 4. We add. We keep going if we want, but this is just going to give us a remainder. The slant asymptote in this case would be y equals x minus 4. And that's just a coincidence that it's the same as that. That is not going to always be the case. All right, what about this case? When the degree in the numerator is less than the degree in the denominator. Anybody know? It's y equals 0, yeah. And we found that by finding the limits to infinity, and then we just said, okay, we're just going to remember that. Talked about this. All right, so here we have a picture of a function, and this is another weird-looking function. It's not a common one that we've seen. So this says, identify the real numbers, x sub o, x sub 1, x sub 2, x sub 3, x sub 4, in the figure such that each of the following is true. So f prime of x equals 0. F prime tells us the derivative. So where would the derivative be 0? Is it going to be true at x sub 1? Oh, I'm sorry. I said x sub 1, but that's just because I can't see. That's x sub 0. So that is going to be x sub 0. Is it going to be right there? Is the slope 0 right there at x sub 0? Yeah, it is. So x sub 0 works. What about here at x sub 1? Is that going to have a slope of 0? No. What about here at x sub 2? Does that have a slope of 0? Yes, it does. But is that a max or a min? So that's what happens sometimes, guys. Sometimes that first derivative is 0. That critical number, though, is not going to be a max or a min, even though the slope right there is 0. Okay, let's keep going. That one doesn't work. That's not a slope of 0. What about x sub 4? Yeah. Okay, part B. F double prime has to equal 0. What does F double prime have to do with? Concavity. So now we're looking at where the concavity is 0, where we change concavities. Are we changing there? No. Now this one, I suspect that this one actually might have a second derivative that's 0. Even though that concavity doesn't change, do you see how we're going like concave up, concave up? A lot of times on that might have that second derivative equal to 0, even though it's not a point of inflection. Do you remember some of these problems we've done with the cusp, where that second derivative ends up being 0, but the concavity test fails? So, I wouldn't count this right or wrong, wrong if you put this, or forgot this rather, but x sub 1 is probably going to have a second derivative equal to 0. At sharp turns or cusps, weird things happen. All right, what about x sub 2? Is our concavity changing? Yeah, so definitely x sub 2 is going to have it. What about at x sub 3? Is our concavity changing? I think it is. So this is concave up, concave down, concave up. So yeah, x sub 3 is also going to be one. X sub 4, probably not. All right, f prime does not exist. Where's f prime does not exist? One spot. What is it? X sub 1. Good. F has a relative maximum. Again, only one of these. What is it? X sub 1. We don't know about, well, we're not even given an x value there. F has a point of inflection. We actually are going to have two of these. Do you guys know what the two are? X sub 2 and x sub 3. Very good. All right.